So in this video, we talk about ACEs. Make sure to check out the lesson in the introduction section of the course about setting up ACEs in Arnold before watching this video. The topic of color management and color science is a very deep topic which can't be covered in an introductory course. What I'm gonna do in this video is to give you an overall understanding of what ACEs is and does. Then I give you a few examples comparing ACEs and the default color manager and show you why ACEs is just way better. And finally, I'll show you how to get your normal sRGB outputs out of an ACEs color managed workflow. ACEs is a system to manage color in all levels of the production, from the actual production and capturing to post-production and finally distribution. If you think of a typical CG workflow, you have different image data coming through in different color spaces like RAW, Rec 709, sRGB, log, and so on. You can get all these different color spaces and capturing formats into ACEs using what's called IDT or Input Device Transform. ACEs manages and consolidates all of them using ACEs CG color space. You work on your scene in the ACEs CG color space. When you are done, you can render your scene out to any format, which is for us normally that should be sRGB with ODT or Output Device Transform. Now, IDT or Input Device Transform is just a fancy term for converting those incoming image data to ACEs. If you have been following the course, that is the moment we select an image node in our shader network and choose something like linear sRGB or raw sRGB and so on. And when we do that, now those image data are in ACEs color space. When we are done with the scene, we can export or render to any output device like monitors using an ODT or Output Device Transform, which simply put is the format you want to render your scene out with. So ACEs CG is the exciting part for us. This is a large gamut linear gamma color space that is intended to be a working space for CG. I really invite you to read up on ACEs if you are interested, and there is a great mini course over at GSG Plus by Chad Ashley that explains ACEs in much more details, and there are tons of great articles on web explaining ACEs painstakingly. Also, there is a good article on Arnold user guide titled ACEs Workflow that I recommend reading it. In the ACEs video in the introduction section, I showed you how to set up ACEs in Arnold. In the render settings under the main tab, come down to the color manager, change the color space to Open Color IO, then load the Open Color IO config file. Then you have this sRGB color space narrow and render color space linear. The render color space should be ACEs CG because if you remember, we want to convert all the incoming image data to ACEs and work in ACEs while working on the scene and preparing it for the final render. And the sRGB color space is the default color space for the incoming images and textures. You can set it to sRGB texture and then change it individually for different incoming images. For example, if the incoming footage is coming from a red camera, when you load that footage in your shader network through an image node, you can go to the red group and choose the specific capturing format for that footage that you loaded using the color space input in the image node. Again, in the ACEs video in the introduction section, I showed how to change the color spaces for different incoming textures and how to change the color space in the IPR to output sRGB. And when we do that in the IPR, we are basically using an ODT or Output Device Transform to output from ACEs to a color space that can be viewed properly on the web and on most monitors, which is sRGB. Before watching the rest of this video, make sure to check out the ACEs video in the introduction section, as there are some essential info there that I won't be repeating them here. Now let's talk about the advantages that we get from working in ACEs. Let me open up this scene 0603 ACEs 01. And this is the same scene for the interior lighting lesson, if you remember in the lighting section. Now this scene is set up with ACEs. If you take a look at the render settings, let's just make sure the IPR color space is output sRGB and run the IPR. Now, this is the type of scene where ACEs really shines. We have a lot of incoming lights through the windows coming from the sky and the distant light. Because we are using ACES, we can keep increasing the intensity of our light sources to emit more light into the scene. And because of the way ACES handles highlights and overexposed areas in the render, we can keep emitting more and more light and energy into the scene, which would be impossible without ACES. Look at the ceiling areas closer to the windows. You can see they look very nice and natural. There is no burnout pixels. It looks like a natural lighting. I'm gonna just take a snapshot for safekeeping, and let's just stop the IPR for now. Now open up this scene called ACES 01 sRGB. Now this is the exact same scene, but it uses the built-in color space, which we can see it in the render settings. I'm gonna change the color space in the IPR to auto and run the IPR. And you can immediately see a tangible advantage for using ACES. Because we are dealing with an interior scene and we need a lot of incoming light to make it natural and realistic, how can we deal with this burnout highlights? The answer is simply ACES, because it has a much wider color gamut. It can handle those overexposed highlights much better. Let's take a snapshot and compare the two render. In the first one, we used ACES, and in the second one, we are using just the built-in color space. Just look at how much ACES is better in preserving those highlight details. Okay, you might say, why don't you just decrease the intensity of the light sources to get rid of the overexposed highlights? Let's do that. I'm just gonna select the Arnold sky and decrease its exposure to 3 and the distant light to maybe 4. Now, the highlights look better, but we are still losing some details there. And if we take a snapshot and compare it to the ACES render, because we don't have enough light, the scene looks much darker, very unrealistic, but the ACES render looks much more realistic because we are letting way more light into the scene and the highlights are not overexposed. So the way ACES handles highlights and preserves details is on another level. Now let me open up this ACES 02 scene. I'm gonna change the IPR color space to output sRGB again and run the IPR. Now this scene is set up with ACES again. In this scene, we are dealing with an extreme scenario with a saturated red light coming through the window, some atmospheric volume, a lot of colorful ceiling lights, and ACES handles these colors pretty well. We get these nice color mixes throughout the scene. There is no hollowing, everything blends naturally. It is really hard to get a similar result outside of ACES for such an extreme scene. Now let's take a snapshot and stop the IPR again. And now open up this ACES 02 sRGB scene. Now this scene uses the built-in color space. Let's change the color space in the IPR to auto and run the IPR. And you can see this color space cannot handle all these extreme colors and lights. Let's take a snapshot and compare it to the previous render. Now here it becomes clear why ACES is clearly the superior color management solution when working in Arnold. It has a much wider gamut and therefore it is capable of handling more incoming light and saturated color. Simply put, it's very good at preserving highlights, shadows, and colors. Now let's quickly open up this 0603 ACES 03 scene. And here ACES is set as the color space. I'm going to change the IPR color space to output sRGB and run the IPR. Now this scene won't be included with the project files. You see how we get these saturated colors blend just nicely. All the highlights details are preserved. If I take a snapshot again and stop the IPR and open up the non-ACES version of the same scene, and change the IPR color space to auto again and run the IPR. Now, if we take a snapshot and compare it to the previous ACES render, you can see how the colors just look more natural. There is a bit more contrast in the highlights and the shadows. It feels and looks better. Obviously, I can make the non-ACES render much better by tweaking the lights and the colors, but as ACES gives you a much wider gamut to work with, in almost all cases, it is superior to the built-in color space. Now, from the ACES video in the introduction section, we know that as Cinema 4D's Picture Viewer does not support OpenColor.io, we cannot render our ACES managed color scenes to the picture viewer. We cannot see the correct result in the picture viewer. So let's talk about exporting from ACES. First, you have to export your ACES as EXRs. So in the render settings, go to the Save tab, define where you want to save the render, change the format to OpenEXR, and set the depth to 16 or 32-bit and start the final render. I tend to use Arnold Driver for my renders. We talk about Arnold Driver in more details later on. For now, let's add an Arnold Driver from the Arnold menu. Choose Driver EXR, and under the main tab, define where you want to save out the render. I have this render folder, so let's put it there in section 06 rendering and name it 0603 ACES 02. I have already rendered that. That's what you see there. Now we can enable half precision to get a 16-bit EXR instead of 32-bit. Under the driver tab, I'm gonna enable these merge AOVs and enable output Arnold denoiser AOV as well, if we wanted to denoise the render later on. And we can use a 1920 by 1080 resolution. And now I can start the render by clicking on this render to picture viewer button. I have already rendered it, so let's go to Fusion and see our ACES render and how we can manipulate it in post using Fusion. So here I am in Fusion. Let's drag in the render. And here is our render. Still in ACES color space, what we see right now is not what we saw in the IPR, and that is because we were using an output transform in the IPR to see the result in an sRGB color space, and that was when we used that output sRGB color space in the IPR. Here we can do the same thing using an OpenIO color space node. So let's add one after our loader node. Now we need to load that same OCIO config file that we used in the Arnold color management section. So let's add it here. Now we have to define a source space and an output space. The source space was ACES CG, if you remember, that was our rendering color space back in Arnold. And the output space is output sRGB. And now if we view this node, we should get the exact render that we saw in the IPR. Now we can go ahead and start color correcting the render, but the problem is we are in sRGB color space right now. And if we start grading, we lose all the benefits of working in ACES in post. So instead of converting the render to sRGB directly, we can convert the ACES CG render to ACES CC color space, start grading, color correcting, and compositing our render. And after we are done, we can go from ACES CC to sRGB again. ACES CC is another color space under ACES. It has a log gamma, but is otherwise identical to ACES CG. It is intended as a working space for grading and compositing applications. Let me create a copy of my nodes and paste them. View the copied OCIO color space node. Now the source space is ACES CG, but the output space is going to be ACES CC. As I mentioned, this color space has a log gamma. That's why it looks so flat right now. We can convert this from ACES CC to out sRGB, and we should get the same result we had before. Now let me copy the OCIO color space again. and set the previous node as the input. And let's view this node. Now the source space is ACES CC and the output space should be output sRGB. Now we are back where we were, but now we can start color grading and post work between these two nodes because that's where the render is in ACES CC color space, which allows for a fully featured color grading in ACES. Let's make some space between these two nodes. Press Shift Space and add a color correction node. Hold on Shift and insert it between these two nodes. Now we can start grading the image and enjoying the benefits of ACES in the post level as well, including its realistic filmic response. And when we are done, we can add a saver node at the end of the chain and render out our image in any format we want, like JPEG or PNG. So in this video, we learned about the ACES workflow in Arnold for Cinema 4D. See you in the next video.